Alrighty, so in this video, we are going to be wrapping this example up. So the first thing I want to do is I want to be able to read in one of those documents that are listed in our awesome unordered list over in that awesome HTML page that we wrote in the last video. Before we do that, though, I want to introduce two conveniences. One's a rudimentary security measure, and the other one is going to make our code a little cleaner. So the first thing, as far as the rudimentary security measure goes, notice that when I click on these links, what it's going to do is it's going to say file equals document2.txt, and we'll want to read in document2.txt from our specified documents directory right here. But because this is a user editable query string, we could do something like file equals /server.js, and then we're getting the source code for our server. Obviously not what we would want to do. You can verify this behavior, by the way, by opening up the REPL. So coming over here into an empty command prompt, typing in node, and saying var path equals require path, var directory equals documents. Now watch what happens when I say path.join directory followed by /server.js. So notice how it just says server.js right there, whereas otherwise it would be just /server. So we really want to sanitize that out. I want to point out that the method of sanitation that I'm going to be using isn't something that you should do in production. There is a file name sanitation library available on NPM, which I would highly recommend you guys use instead, but we'll be talking about NPM in the future. And besides, I wanted an excuse to write some regular expressions. So I'm going to write a regular expression that will filter out potentially dangerous paths, because it gets a little bit more complicated, because I could even do something like directory // server.js, and you see here we still get server.js. So I want to sanitize all // and all slashes from the beginning of the string, and I also want to sanitize out all .. in the entirety of the string. So what I'm going to do is I'm going to write a regular expression to do that. And my favorite tool for writing regular expressions is regex101.com. Now there's a variety of these little regex IDs available online, and you can use whichever one you're comfortable with. It's just this one is typically my go-to. So when starting a regular expression, what I like to do is I like to write a bunch of lines of text in my test string field of things that I want to filter or filter out. So I'll start off with the valid one. I'll say document.txt or sub / document.txt or even sub / document.txt. All of these are what I would consider to be valid paths. An invalid path would be something like / server.js, or it would be / home Nelson finances or something like that. And then another case that I want to filter out is going to be document or sub .. server.js. So I want these lines to match a regular expression, but I don't want it to match these lines. So to do that, the first thing I'm going to do is handle the .. and the slash here. So I'm going to start off the regular expression with a caret, which, as you can see, while you write your regular expression, over here it'll explain the regular expression as you type, and I think that's really cool. So the first thing is I only want to match the start of the line, and then I'm going to open up square brackets. And the square brackets denote a list of single characters that we want to match. Now the characters I want to match is a dot, and then a /. Now the / is a special character in regular expression, so we need to make sure we use the / to escape it. And then I want to also match backslashes, which requires 2 backslashes because we need to escape the / character, because the / character in and of itself is the escape character. Now, to make it test so that it tests each individual line, I'm going to say M, but then I'm also going to say G. So M means multi-line, G means global, and this will basically think of it in terms of rerunning the regular expression on each individual line and then highlighting the matches when they appear. So the second thing I want to match are these .. in the middle, and that's really easy to do. I'm going to come up here to the regular expression and add a pipe here, and then I'm also going to throw in a /dot. And the reason I have to escape the dot character in this context is because, generally speaking, the dot character in regular expressions refers to any any character or any symbol. So this regular expression looks good. If it passes, that means it's a path that is likely dangerous. Again, I want an excuse to show you guys this tool and write out some regular expressions. In production, I would highly recommend using a actual Node package to handle the sanitation for you because it's a solved problem. All right, jumping out of regex 101, I have this regular expression on my clipboard. I hit Control-C on that. I'm going to hop back over to our server.js, and at the top of the file, I'm going to add a regular expression. It's going to simply be invalid file regex. And then I'm going to say equals. Then to turn it into a regular expression object, I'm going to do / followed by the regular expression, and then another /. And note that we do not have to add the GM modifiers to this regular expression in this context. So this will actually turn it into a JavaScript regular expression object for us that we can use later in the code. Okay, the second convenience method that I want to write is going to be something that I'll use in the case of errors. And all it's going to do is it's going to write out ahead of a specified status code of content type text plain and then write some text out. So it's just going to make writing our code a little easier. So I'm going to hop all the way down to the bottom of the file and add this at the bottom here. And it's going to be simply function write text res. So it's going to accept a result stream object from our HTTP server. And basically, like I said, all it's going to do is we're going to write ahead. Whoops. It's going to accept a res, a status, HTTP status, and a text. So the first thing it's going to do is it's going to say red write head, passing in the status code that we want. And then for the headers, it's going to pass in content-type of text plain to tell the browser that it's plain text and not HTML. And then it's going to pass in, or then it's going to invoke res end text. So again, this is just a convenience method because we want to add some error handling to our code, and I don't want to have to repeat res write head all the time. So I just wrote this simple function to clean up our code a bit. So now what we can do is we can jump all the way up to the top of the file, and we can modify our server callback function. So what I'm going to do here is before we invoke write index, I'm going to say var query equals url.parse, passing in rec url dot query. I am going to go ahead and also specify the true as the second parameter to url.parse. And what that's going to do is it's going to use the query string module, which it's going to use its own query string module, not necessarily the one that we imported here, to parse out the query string for us. So make sure to add comma true after url.parse. Then what we're going to get back is a object representing the query string. So I can test that by simply saying console log query, coming back to our server, hitting Control-C, hitting up arrow, so we have a new server, coming back here and clicking on one of these items. And so you see here that we are indeed getting our query string printed out. You'll also notice these additional requests happening. That's my browser trying to get the favicon of this page, which is not something that we're concerned about at the moment. So you can ignore those empty curlies there. So now we see we're getting an object with the file parameter. So now what we can do is I can say if query.file, then I'm going to say handle file, or how about write file, passing in our rec, our res, and our query string, and then I'll simply early exit. The early exit is important here so that after we write the file to the stream, we don't rewrite the index here. You can kind of think of the write index here as the default case if in the previous bit of logic it didn't get already handled. So of course the write file method does not exist. So let's jump all the way down to the bottom of this file here. And after write index, but before write text, I'm going to say function write file rec res query. And what I'm going to do here is I'm simply going to read in the file. Before I do that, I need to test to make sure that the file name is valid. So I'm going to say, I already forgot the name of that regex, invalid file regex. I'm going to say invalid file regex dot test query dot file. So if they're trying to do something malicious, then I'm going to say write text, and I'm going to pass in our result object a 400 status code, meaning bad input. Well, we could get a little bit more specific with our HTTP status codes, but I'm not interested in doing that right now. And then for our message, say invalid file name. And then I'll do an early exit right here. So now if I come back here and restart our server, and come over here, notice how... oh, right. I'll just do that real fast, and then restart our server again. So now if I try to do /server.js, notice how I get an invalid file name with the appropriate status code. Notice how we get a 400 bad request as our status code here. Okay, so now that we've done that, let's replace that garbage code right there, and let's go ahead and read in the file. So I'm simply going to do fs.readFile, or whoops, I'm going to go ahead and create the file name first. So the file name is going to equal to path join directory comma query.file to create the full file name, and then I'm going to go ahead and say fs.readFile, passing in the file name, and then followed by a callback of error and buffer. And then up here, what I'm going to do is I'm going to say if error, then write text res 400 error, and then return. If not error, then I'm going to say res.end. Well, actually, no, I'm going to say write text res 200 to indicate success, buffer.toString, so that we actually get the contents of the file out. Now let's go ahead and restart our server. Come up over here, and I'm going to go ahead and nuke this query string so we get our index again. I'm going to click document 1, and now we have document 1 being rendered to the stream, and then document 3, and so on. Now, we'll see another example later in the series where we can actually use streams to stream the file to the server, which is really important, especially when we're working with Gulp, but we'll talk about that later. So now that we have that, let's go ahead and handle our creation of files. So this is going to be fun. Jumping up back to the top, what I want to do is, before we parse out the query string, I want to go ahead and determine if the user got to this page by hitting the submit button. So what's the difference between the user just visiting this page and the user hitting the submit button? Well, you'll notice the difference is going to be with what method is used to request it. See, when I hit the submit button, you'll notice that we do a post request, which this is too small. This is such a small resolution, you're not going to see it. But we do a post request, and if we just hit this, we'll do a normal GET request. And of course, I forgot it's under general. So we see request method get, and then if we hit this, we'll get a request method of post. So how do we detect that? Well, actually, it's very, very simple to do. If we simply add another if statement, we're going to say if rec method equals post, then I'm going to say handle post rec res, and then return. So, of course, the handle post method isn't created yet. You can kind of look at this as a very rudimentary routing system if you're familiar with other, maybe some MVC frameworks. But the point is if the browser made a post request, we'll invoke the handle post method. So let's go ahead and write that. Jumping down to the bottom of the file, after write file, I'm going to say function handle post rec res. Now, the first thing I'm going to do is I want to go ahead and get all of the body data. So I want to get all of the data that was returned or sent by the browser. And I can do this by taking advantage of streams. So I can go ahead and say var body equals empty string. Now remember, the request object is a string or stream. It will stream in the data from the browser as it happens. So we need to handle this asynchronously. Again, this is another Nodism that's very important to understand. And this code that I'm about to write is going to become very important to understand when it comes to using things like Gulp. So I'm going to do rec.onData function data and say body plus equals data. And then I'm going to say rec on end function and then I'm going to say, in this case, I'm going to say console log body, just for now, so we can kind of debug this to make sure everything's working in the right way. So notice how I'm doing rec on data and rec on end. You can kind of think of the rec stream, the request stream, as the opposite of the result stream. In fact, it is. The rec stream is a read stream, whereas the result stream is a write stream. So because the request stream is a read stream, we can add an event handler using the on method, and the event handler of data will be invoked every time there's more data that the browser is sending to the server. So we can sit there, we kind of aggregate the data as it comes in, as it streams into our application. But then we need to handle the event of when the stream is over. So when the browser has indicated to the server that there's no more data to send, we need to handle that and actually process the data that we've accumulated over all these data events. So let's go ahead and test this real fast. I'm going to restart my server, and I'm going to go ahead and I'm going to put I'm going to open up my browser, and I'm going to put my browser over here, and I'm going to type in some post data, hey, and then stuff and things. So we'll do hey.txt for the file name, stuff and things for the content. Now when I hit submit, check that out. This is the data that's being sent raw by the browser. Now notice that's not particularly useful because it's file equals hey and everything's URL encoded and it's kind of messy. So we need to go ahead and convert that into a data structure that we can actually understand. Fortunately, we can use the query string library to do that. So hopping back over into here, the first step in our handle post method after we've received the end of the request stream is to go ahead and parse out this data. So what I'm going to do is I'm going to say var form equals query string dot parse body. And that's it. We now have an object that represents that data. Then I'm going to say if not form file. So if they did not provide a file name, or what did I call that guy? Invalid file regex test form file, or if they used an invalid file, then we're going to write text passing in res 400 and then invalid. Yeah. Apparently I can't type. Invalid path, and then we'll do an early exit out of this closure. Then what I'm going to do is I'm just going to use the synchronous writing file method. So I'm going to say try fs write file sync, passing in path.join directory form.file, and then I'm going to pass in form.text as the data. Then at the end of this, I'm going to say write index rec res. Then I'm going to say cache e, or ex, whatever, and I'm going to say write text res 400 could not save file, and just for debugging purposes, I'll say console.error ex. So you'll notice here what I'm doing is I'm using the synchronous write file method, and I'm wrapping it in a try catch block. So if anything goes wrong, this catch block will proc, and we will send this result back to the browser saying we couldn't save the file, and then we'll console log out the error for further debugging purposes. Now, if it succeeds, if fs.writeFileSync succeeds in writing this file with this text, we're going to return the right index. So we're kind of hopping all the way back to the index and having it do its own processing after we've written the file. So that's pretty cool. So let's go ahead and test it. Make sure you go ahead and restart your server. Now I'm going to hop back into my index, and let's just go ahead. I'm going to do this, and let's say document4.txt. Hello, this is document4, and hit submit. Check that out. Document4.txt is now here. If I click on it, it says, hello, this is document4. We can verify it's on the file system by hopping back over to code, opening our Solution Explorer, and noticing document4 has appeared in our documents folder. Now we can also use this to overwrite files. So I can go ahead and say document1.txt and say not anymore or bleh or something, and then hit submit. And now notice how no additional file appeared, but if I click on document1.txt, we see its text that we just overwrote it with. So yeah, so in this video, we got an opportunity to write some more Node code. We got an opportunity to look at some more synchronous and asynchronous invocation of different methods, and an opportunity to take a look at streams, which are very, 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 very important, whether you're using Node as an application development platform, or you're using it as a build tool, or a scripting tool even. So I think that pretty much wraps up the crash course into Node. We're going to look at NPM next, which is pretty much one of the biggest benefits to using Node in our applications and development lifecycle. So we'll see you guys in the next video.